Hello, and welcome to the 3D Modeling Society. I'm the president, Christy, and I'm going to take you now through a introduction to our society and what 3D actually is. So, what is 3D? Probably some of you might have heard of it, some of you maybe not. Some of you might be actually versed in software. But I think it is a good idea to make sure that everyone is on the same page and everyone has the same kind of knowledge uh, in the subject. So let's start with the beginning. What is CGI? Well, CGI stands for Computer Generated Imagery, and it in effect means anything made on a computer. So it'll be an image, an animation, or even simulations, all fall under CGI. Now, why would you want to learn CGI? Well, it is a rapidly growing sector. It has effectively been incorporated in every possible industry, maybe save for a couple of them, and it is of exceptional use for anything from technical to artistic disciplines. And this is because of its amazing ability to visualize, allows you to visualize data, objects, or your imagination really in an unprecedented manner. Now, if this doesn't excite you enough, probably the fact that it is now valued at over $32 billion might. And it is only going to grow in the next couple of years, set to reach something like 50 billion around 2030. So now is a perfect time to start getting into this amazing industry. Now, as I mentioned, CGI is a growing industry that has expanded into effectively every possible discipline. So let's take a look at some of these. First of all, let's take a look at the technical ones. Probably there's none other than engineering has been more influenced by CGI. Engineers, in order to especially design parts, need to draw. So if you do engineering, you probably have done some kind of drawing, especially technical kind. And that's going to require you to make a drawing for every single angle of your part, and that's going to take a long while. Not to mention that a 2D drawing is not going to be as easy to interpret or observe as a 3D one, which is why 3D has been incorporated into engineering so much. 3D printing is another aspect that has been introduced into engineering through CGI, as objects that are created in a 3D modeling software can now be printed, usually in plastic, although engineers would also have access to things like metal printing. And what softwares are used for these? Well, CATIA is probably one of the best ones, especially for designing parts. If you do engineering at UCL, you probably learn CATIA. It has very good designing and measurement tools, allows you to create very complex machinery inside of it, and it is just generally great for these kinds of applications. For 3D printing, a simple software such as Fusion 360 would do. It is made by Autodesk, a company that makes lots of these kinds of software. It is relatively simplistic compared to its other software, but it is perfect for 3D printing specifically because of that, because all you want to do is do simple modeling, for example, or simple additions to your already made model from a different software, and then make sure it is good to be exported to a printer. And there is, of course, software such as SolidWorks, which kind of takes the best of both worlds. And in general, I've seen people use SolidWorks for both 3D printing and the design part. So it is good for either. Architecture is another important technical discipline that has been thoroughly influenced by the 3D industry. Most importantly, probably building design. So just like in engineering with part design, here buildings would need to be designed usually on paper through a blueprint. Uh, Also, architects would often make an object or like a building as an actual to scale model, which takes time, and if you make a mistake, you have to start all over again, probably. 3D doesn't have this issue because you can always just use you could just go redo or undo as things go on. Not to mention that you have save files and all these things you can return to. ArchViz is another new discipline that has arose as a result of the 3D industry. ArchViz involves architectural visualization, that's what it means, and usually it is used for presenting your building, your interior to a person, to an investor or to someone you want to sell it to. And you would usually do this like the traditional way by literally having a blank room and putting actual things in it and looking how lighting would work inside of it. It is preposterous, but that's how it was done. But now with the advent of 3D modeling software, you don't need to do that anymore. You can just model objects or have them modeled by someone else, and you just introduce them and arrange them the way you wanted them. For software, probably many of you have heard of software such as SketchUp. Google SketchUp is fairly simplistic in its um, design, but it is actually quite complex. Now, I wouldn't say that it is the best software. It is okay for architecture, but it only really serves as a way to build relatively blank models of a building. So things like color, texture to a surface can't really be added any way properly through SketchUp. For that, I would prefer software such as Blender, which is great, especially for architectural visualization, as it has lots of these um, texturing and material options. Not to mention a lot of great lighting algorithms are inbuilt within it. But what if you're a scientist? Well, 3D has been introduced into science for a long time, and specifically in simulation. So scientists used to do simulations literally just as numbers and then plot them using other things. Now, of course, we have plotting software, and eventually these evolved into proper 3D simulations. These can go from anything from simulating a galaxy to simulating a protein folding to molecules interacting in a chemical manner. All of these are things that can be simulated. Now, because of the complex nature of science, you should expect the fact that many software exists, each with their own little addition. So there might be a software for chemistry, for a specific part of chemistry, for a specific part of physics or biology, and it'd be impossible for me to give you an exhaustive list. So I'm just gonna give you the one that I know how to use, at least kind of. COMSOL. COMSOL is a mainly physics and engineering software that allows you to, well, simulate multiphysics. So usually you'd have one software for, let's say, magnetic fields, one for electric fields, one for for fluid dynamics, etc., etc. And if you wanted to make a system that combines them all, you'd be impossible normally. Well, COMSOL solves that problem by having them all in one software, and you can see how they interact. So I would say COMSOL is a great software for these kinds of things. Now, let's go away from science and let's take a look at artistic disciplines. So first, images, of course. If you have seen a cool image, probably something like the one you see here with this little with these mountains and hot air balloon. These kind of things are done in a kind of step-by-step process. So the first step usually is something like modeling. So you actually model the objects inside of it and create the actual scene in terms of actual solid objects that are within it. Then you would do something called texturing or shading, which involves giving them color, texture, certain surface, how light would reflect off them. All of these are done in texturing. But what if you want to make something that is more organic? Because modeling usually involves a very hard surface kind of shapes. For that, you have things like sculpting, and sculpting allows you to work in a kind of digital clay. So if you ever done any kind of clay sculpting, this is the kind of thing you're dealing with, and it involves actually you using something called brushes, and you are working effectively the same way as you'd work with normal clay, except you're using your mouse except instead of your hands or tools. Software wise, for modeling, there are software such as Maya. Maya is, you could say, the OG of modeling software. It is the original 3D software, almost. Not really. I won't say necessarily, okay, not quite the original, but it is the industry standard. If you were to work for a 3D modeling or some kind of CGI company, it is almost certain they're going to use Maya. For texturing and shading, there are many software, but I would suggest Substance. It is probably one of the most, if not the most used one out there. It is again one of the industry standards, and it is actually two software. So there's Substance Designer, which creates the actual materials and surfaces, and there's Substance Painter, which adds them to the actual models. And finally, ZBrush will be for sculpting, which is again, this is not an industry standard software. It is a very powerful one that allows you to make exceptionally realistic objects with it. And it is, if you were to have, let's say, a graphics tablet, you could sculpt it almost identically to how you sculpt in clay. It is just the fact that you're touching a screen. But of course, I would suggest something like Blender. Blender is probably the software that I would say is the best for just general learning, because it involves all of these things in one. So definitely a very good one. It isn't technically an industry standard, but it is, and it isn't technically as good in the individual ones as maybe Maya, Substance, or ZBrush, but it is good enough for almost everything. But what about if you want to make your images move? Well, for animation, you'd use, again, another step-by-step process. So once you've had created your objects, your scene, as a still image, to animate them, you'd use something called keyframing. Keyframing involves, well, starting with an object in a certain position, then saying, a couple seconds later, move to this position. And then the computer will then interpolate. This means creating a curve between the two points. And depending on how that curve is shaped, you can determine its speed, its path, and many other aspects of the movement. This is the most basic and most important tool in animation. Rigging is also important if you do any kind of characters. So characters, you might expect, would have to move around in different ways. And for this, you need to create a rig. A rig is, in effect, the skeleton of the character. And once you've created that, you can move each joint independently depending on either keyframes that you set or using movement from a camera. So you can do something called motion tracking. If you've played any games, they likely have used some kind of motion tracking to make their characters move around. And finally, you can do simulations. So just like in science, you can do physics simulations inside of 3D software. Now, this is because you might want to make a more realistic kind of movement. And there's no way you could keyframe it just right to make it look natural. So that's why we have simulations. I wouldn't say there is one software good for all of these, but again, Maya is an industry standard, great for it. Cinema 4D is another one that can also do modeling, texturing, etc., and is especially used for animations. And again, Blender is great for all of these. So now let's take a look at the society. Now that you know everything, now that you have been introduced to the CGI world. So why us? Why have we even made this society? This society was created with the sheer purpose of bringing people to learn about 3D, to introduce you to the world of 3D. Because I think far too few people actually know about it. Far too few people have any kind of knowledge about it. And that's mainly because the fault of the 3D industry, I would say. When you see these amazing simulations or animations or images, you might be just scared seeing just how complex, how interesting, how realistic. You might think, oh, that's impossible for me to do. If you ever were to open a 3D software, just seeing all the different buttons, all the different options, it's daunting. And I would say that many people would probably are put off by that. It's certainly something that scares many. But that's why we are here. We want you to learn the software, and we will help you to do it in a interactive and fun way, and so that you don't have to go alone in it. I can say from experience it is hard going alone. So having someone to introduce you to it is certainly very valuable, and I hope that everyone can appreciate that. Also, we hope that you will be able to gain new skills through our society that you can then use in either your own field or in a completely different field. So, for example, you might be studying engineering, and you might use the skills you learn in our society to apply in your future job. Or you could use them to get a graphics designer position somewhere. Either way, we would love you to gain these skills that you can then transfer to a variety of different places. But if we were all about learning, we would not be calling ourselves a 3D modeling society, but rather something more like 3DMS 0054 3D modeling course for UCL beginners, which is not the case, because we want to create a strong community, a friendly environment for everyone to be able to meet new people and find people that you can resonate with. Um, we want to create this strong family, this community of people who want to learn about 3D, who want to understand it, who want to express themselves and to create, to invent, to innovate. And this is why we have created the 3D Modeling Society. So, what do we offer? We offer courses in a variety of software. These courses will be weekly, roughly 1 to 1.5 hour classes, and they'll be mainly about understanding the basics of different software such as Blender, CATIA, and Gaia. If you have never ever even touched 3D software, you don't have to worry because you don't need any kind of experience. We will teach you how to make a simple scene, kind of like a little RStudio. That's what we're going to make initially. And this will be done on a step-by-step basis. We will introduce you to the UI, to every single little concept of 3D, so you don't have to know anything about it. So you don't have to now go out and start learning. Although, if you want to, there are plenty of tutorials out there to help you with that. We also will provide 1 to 2 long hour sessions, 1 to 2 sessions that will be for master classes. These will be in parallel, separate from the beginner courses. These are meant to introduce you to more either complex or specific aspects of a software, or to a very niche software that we can't really teach in a full course. This can be anything from how to 3D model, how to 3D print models that you've created, all the little intricacies of shading and materials, character modeling, perhaps even photo scanning, etc., etc. But as I said before, we don't want to be just all about teaching, so that's why we have online socials and critique nights. So we'll have coffee chats, online games, field screenings, just general events for you to meet people, talk, discuss anything you really want, really, and have fun. These don't have to be 3D related, although they can be if you want to. They can be just for fun, or we could just start um, laughing at just how terrible 3D modeling might be in a particular movie, or mesmerized at it. We can be both good and bad people here. Um, we also provide show and tell sessions, and these would be kind of like critique nights that you can show off your projects and inventions and ask for feedback from fellow students, the committee, and in general just have fun showing off your designs, or just getting perhaps ideas for your next one. What about our committee? So this is me. I'm the president. Uh, Treasurer is James Marsden, fellow physics student, astrophysics student specifically. Our publicity officer is Alex, and we have also have two new people to our team. Keshin is our events officer, and Ashley is our welfare officer. But this is not all. We still need people to help us with the teaching and the development of the society. So if you know any kind of 3D software, whether it be a more niche one or a industry standard, please do message us if you're interested in um, sharing your knowledge and your expertise, because we would be more than happy to have you on our team. So with that out of the way, let's see quickly what you will learn at our society. So the short answer is Blender. So I think I've said Blender quite a few times already, and it's for a good reason. It is a great software for getting into 3D and just generally doing anything in 3D modeling, CGI, animation, etc. The reason? Well, it's free. So almost all of the software I have mentioned, other than Blender, uh, cost quite a bit of money. They can range from a couple hundred to several $1,000s. And many don't even have a perpetual license, usually a subscription one. Now, if you're a student, which you are, you can get probably either a discount or a kind of student license for maybe a couple years or as long as you're a student. But while you can do that, once you finish your time at UCL or any institution for that matter, you won't be able to use it anymore. And that's why Blender is great, because it allows you to use it for free anytime and forever. And it is given for free to us by the Blender Foundation, a Dutch um, charity which has created Blender. So thank you very much for that. Another reason to use Blender it is because it's very versatile. So as I said, many parts of the 3D industry usually use multiple software. So you have one for sculpting, one for modeling, one for animation, and that's great if you can afford it, because they are more specialized for the individual part. But many cannot afford to buy all the software, let alone even one. So that's why Blender combines all of these possibilities into one single software, and it gives you amazing versatility. Now, even though Blender is technically not a industry standard software, ever since 2019, when the 2.8 update came, Blender is effectively on par with software like Maya, because it has received an outstanding amount of improvement over the years, especially with this update. New features, lots of quality of life improvements, and it is now effectively just as good. The only reason other companies are not moving to it is because pipelines, and it would cost them more money to change the whole training process of their artists, and it's just cheaper to just stay with the exceptionally expensive software. But new companies that are forming right now are choosing Blender over the other ones. But it's true, Blender does not have perhaps all of the features that other software have. But this is solved through something called open sourcing. So because software like Blender are open source, people can develop their own add-ons, and this is exactly what happened with Blender. You can only add so many features when you have a limited amount of time, a limited amount of manpower. But when you make it open source, anyone can make their own addition to the software. And Blender has an exceptional amount of add-ons which you can get either for free or you pay money for them depending on the case. It's really your choice here. Down here you see an image that was made in Blender. This was made by the Blender Foundation and this is part of a little open movie called Spring. And it is a really nice movie. It is Pixar, how could you say, in a Pixar style, you could say it is almost indistinguishable from one made by Disney. So it is exceptionally well made, and it is made 100% in Blender. So you could, if you get really good at Blender, you could make something like this eventually. Now let's take a look at what you can do with Blender. First of all, as I said, modeling. You will learn about geometry and topology. Here refers to the actual things that an object is made. These are vertices, edges, faces, etc. All the different terms that you need to know about. You'll also learn how to build objects in edit mode and also how to use modifiers to change the shapes of your objects. Sculpting, again, it is another important part of modeling. It is not essential in every project, but if you want to make especially organic looking meshes, you need sculpting. So you'll learn to use the variety of brushes that exist in Blender and also how to do retopology, which involves just creating a less detailed version of your object, especially if you want to bring it into a game that you're making in something like Unity or Unreal Engine. Shading or texturing is an important part because otherwise you will have just gray or a blank color on your surface, so it wouldn't be very interesting. You learn how to use the Blender Node Editor, which you can use to create a very complex looking surfaces, and you will also learn how to create your own textures and maps, which you can learn how to do in our own courses. Finally, animation is, of course, if you want to make an image, you can just stop here, but animation is another important part of the CGI industry, and you learn how to use keyframes and a dope sheet and timeline. Within Blender, what you're seeing here is something called the dope sheet, which each point that you see is called a keyframe, and as I mentioned before, they are just the individual points where a movement would start and finish. But that's, of course, just a small part of 3D. We will learn in our master classes how to use things like particles, physics simulations, 3D printing, rigging, and motion capture and VFX. All of these you will be able to learn in our society. And these are all doable with Blender. Other software that you learn is Gaia. Gaia is a rather simplistic software in terms of its scale, of its scope, because it is only used for creating realistic terrain. But the reason it is great is because if you wanted to make such realistic terrain in Blender or any other 3D software, you wouldn't be able to, not properly at least, because all the intricacies of a true realistic terrain cannot be properly made by pure sculpting unless you're some sculpting guru. Which is why you have software like Gaia, which uses air erosion and other algorithms to create these realistic looking terrains. And it also uses a node system, just like textures, so you should be at home with it once you learn how to use texturing. And finally, we hope to be able to bring to you also courses in software such as CATIA for engineers, which, as you can see here, is a great software for creating engineering parts of any kind, and you could even export them to be 3D printed, although not probably something quite as complex as Turbine. And I will also hope that I can bring to you at least a masterclass in COMSOL. As you can see, it is a very versatile software. It is exceptionally complex, but it is a software that you certainly can benefit from if you learn from it. So now, if you have any questions, please do write them in the comments or on our Facebook page. Whenever you feel like there's something that you don't understand, don't hesitate to give us an email, and we would try to answer as quickly as possible. So, till next time, stay safe and welcome to the 3D Modeling Society.